your host, Grayson Brulte. Welcome to another episode of SAE Tomorrow Today, a show about emerging technology and trends in mobility with leaders and innovators who make it all happen. On today's episode, we're absolutely honored to be joined by Dr. Armond Sinclair, Senior Technical Account Executive, Ansys. On today's episode, we'll discuss the adoption of digital engineering and how it could drive faster, smarter decision-making. We hope you enjoy this episode. Dr. Sinclair, welcome to the podcast.
Thank you for having me.
It's wonderful to have you here because digital is changing the civilian industries, but it's also changing government industries. The Department of Defense is looking at implementing a digital engineering strategy. How important is that for the department?
It's extremely important. I mean, we're seeing as of maybe 18 months ago, a mandate come out from the Department of Defense. Anyone who's in the space is familiar with DODI 5097 that basically states that thou shalt execute and engage in digital engineering on defense programs from this date moving forward. But to be honest, it had legs prior to that, dating prior to 2018, 2017 with the Digital Engineering Handbook. The Undersecretary of Defense for Digital Engineering Modeling and Simulation has been very forward-leaning to getting the community involved in sharing best practices, trying to cross-pollinate to make sure that we're leveraging the best practices so that we can have successful programs. So, I mean, it's very, very important, so much so that it's a requirement for all new defense programs moving forward.
What was the backstory of this? How did it come about? Was it efficiency? Was it cost savings? What was the backstory that made this, as you said, extremely important?
I don't want to misspeak on the backstory because I wasn't there at the origins. I came in around 2018, 2019 when MBSE was really starting to take off. We started seeing evidence of what multidisciplinary design, optimization, and analysis could do. I believe Northrop Grumman laid out one of the most eloquent displays of showing that if you had a baseline design, you could optimize it based on requirements and constraints such as speed, weight, cost, the various parameters. But as we continue to move forward, things such as authoritative sources of truths and integrations and migrating away from document-based and siloed-based practices to an integrated ecosystem with workflows where data could move bidirectionally and there was traceability started becoming more important. And as that continued to gain momentum and we're seeing some of those industry leaders such as Lockheed Martin, Northrop Grumman, Boeing, pushing the frontier of that and working with the defense agencies, we start seeing that morph into what became the DoD 5097. A lot of that effort was led by Phil Zimmerman, who was one of call her the godmother of digital engineering. She did a lot of great groundwork establishing communities of practice where academia, industry, and government could come together to discuss what were the pain points, what were the advantages, and how we should move forward.
Do you see it between contractors and the department unlocking more collaboration?
It's extremely collaborative moving from my perspective, at least the vantage point that I've seen. The government has been really open with examining recommendations, putting together review boards of industry experts that could, establish standards, address pain points so that we're not repeating past mistakes, and then also bringing lessons learned and appropriate use cases to the table so that we could shape it the way it needs to be.
Before we really unpack digital engineering, there are some of our listeners who might not be familiar with the term. How would you describe it to those listeners?
I would say we're very accustomed to siloed engineering where our tools are very disparate. I mean, PLM, if you look at these tools in their own right, nothing's truly novel. I think PLM has been around for decades. You make a drawing, you release a drawing, have your bomb. But when you start looking at integration and automation, traceability, and you're able to have authoritative sources of truths and within each of those disciplines or focus areas, you're able to have config management, and you're able to have that bidirectional traceability and understand if I make a change, what all is impacted throughout the entire life cycle. That's where we start really seeing the power of digital engineering. So when I tell people, when someone asks me, what is digital engineering? I tell them, look, think about it as an integrated ecosystem of tools that are dictated based off of your product or program's requirements or needs. And I want to also just state that, just because you have a digital engineering ecosystem doesn't mean that you're going to manufacture or produce a great product. I mean, if you don't have good ontologies, processes, workflows, or good engineering rigor, you're going to still put in garbage in is garbage out, as the old proverb says. So I don't want to say that, digital engineering is a magic wand that you can wave at your engineering workforce and all of your problems go away. But if you have good processes, you have good engineering standards and practices, it can help shift a lot of things to the left, your schedule, and you can fail early, make discoveries earlier before you start getting into manufacturing, and make the course corrections that are needed so that you can manufacture a really good product.
You're 100% right, and you said it right. You need accountability. We see that in the military. From a DoD perspective, do you see a digital engineering strategy unlocking efficiency, and perhaps moving the timelines a little bit quicker than they've historically been?
So I'm a dreamer in the digital engineering world. Let me say that first and foremost. So I always think about what is the best capabilities that we can unlock. I always look at it from that perspective. I think I'm a CFO's nightmare because of the cost that would be associated to do said things. But if you had a really mature digital engineering ecosystem, especially from a DoD perspective, I mean, you can actually go to do AOAs or, analysis of alternatives down to the component level within your system or system of systems and put them in theater campaigns and run mission simulations to see how will it impact the warfighter. And so those are, when you start getting into those type of sophisticated workflows and ecosystems, the power of digital engineering really begins to shine. I mean, when you're looking at, I'm not going to reveal the name because, we're still in early discussions, but we have a technology partner that we're working with that we can do campaign simulations and portfolio optimizations. And why is that important? The DoD, you typically and historically, when it comes to weapon systems, have said, we have threat X, we need a solution, and here are those system requirements. And that's what everyone goes off to address. But very seldom do we say how many of those assets do we need and where do we need them placed. And so we're able to now run simulations with that portfolio optimization in place, where and have multi-base defense. We're able to see how would it impact a red force versus blue force at a campaign level at a theater. So, a China versus Russia versus US type of environment. And we can plug and play our subsystems and components and see how does that impact. So, I mean, it gets very sophisticated. So from a DoD perspective, digital engineering is absolutely essential and needed within today's time.
Are they starting to teach digital engineering at the war colleges? Has it gotten down to that level yet?
I haven't. I know that there are some classes like at DAU. I haven't been too involved with the war colleges per se, but I know Defense Acquisition University has a lot of some of the core classes that you can sign up for, MBSE, things of that nature. But I don't have a good knowledge on their exhaustive portfolio of offerings.
I'm going to put on my kid hat here. You're playing a really advanced game of Risk, and it's really neat there. If you look at simulation in the civilian sector, in automotive, in aerospace, the amount of cost efficiencies that are being uncut with it, the amount of efficiencies, the moving technology, it's all widely documented in the civilian sector. So I can just imagine in the defense sector what it's doing there. Earlier, you said authoritative source of truth. What distinguishes an authoritative source of truth?
So I'll say this. I'll give this an example, and I think this may be telling of my age, but let's speak simulation specifically. If I have an engineer that's doing CFD analysis on, let's say, an external fuel tank, that simulation may have been executed, and they'll send off the results to all stakeholders that have an interest in that. But there isn't a lot of config control oftentimes on where that analysis resides, where that data resides. We want to make sure that when we're doing our simulations and our analysis or any type of engineering work, when it's released, that we have good configuration control and config management over those artifacts, and that we know who touched them and where that data is flowing and where they're being attached to, what engineering work packages they're being associated and affiliated with. I've seen some organizations that have done some engineering practices that should be almost criminal for DoD practices, where their documents are held on a SharePoint, and that's where config management happens. And also on local desktops. And we have to get away from that when we're talking about taxpayer dollars and accountability and making sure that we have the most up-to-date versions and releases. It's essential and imperative that we have an authoritative source of truth with that, whether it's for simulation, drawing releases, et cetera, or models, MBSE models. We need to make sure that we have the most up-to-date version, that everyone has access to what is relevant and what is obsolete.
Is there an audit log on the backside of this?
Well, I think that would be predicated on your level of maturity and what tools and design that you have for your ecosystem and what capabilities your organization or program signed up for. And, I want to say this, digital engineering, like I said, it's such so many different combinations of how you get there. There's each tool and vendor can represent a paint or paint brand. And, you get to select what tools you have and what combinations that you're going to integrate them. So there's almost an infinite number of ecosystems that you can build. And I think it's really predicated on what your organization or program needs are and what capabilities or maturity levels you are required to perform at. So to answer that question, it depends on what constitutes digital engineering for your organization or program.
Are we to the point where digital engineering can enhance decision making? Are we that mature yet?
Absolutely. Absolutely, we are. I think Will Roper, former Assistant Secretary of the Air Force, who's, my gosh, a very known, I would call him the Neo of from the matrix of digital engineering. I remember having a conversation with him, and he said, no one has successfully implemented digital engineering across their enterprise. And that's a true statement. Unless you're a small startup, where you have the ability to deploy an ecosystem across, your one or two programs. When you look at these big primes, like B2 program is not going to go fully digital. It's not a good return on investment. They're not going to migrate all of that data. But to answer your question, there's a lot of pockets and silos of excellence where digital engineering does exist in some of these high-performing defense organizations where they're seeing the value of digital engineering. Kathy Warden, credits digital engineering to the success of B-21, during their maiden or their release party to the public, and talks about how digital engineering helped them stay on schedule and on budget. So those capabilities that come with digital engineering help decision makers, especially when you start getting into, program integration and into your digital ecosystem where now you're looking at your schedule and your costs that are associated with it. You can absolutely make sure that you leverage those capabilities in your ecosystem. It's really about how mature do you want your ecosystem to be in that capacity.
Will the emergence of the Silicon Valley's focus on American dynamism, which is being led by A16Z, and then you have Anduril, now you have Applied Intuition building a big defense and making an acquisition, does that accelerate this because now there's a lot of money behind this?
Well, I love those organizations because they're so innovative in their spaces and very disruptive. And I think that they bring the ability to put pressure on the traditional mindsets that are very slow to turn. Right now, if we're being honest, a lot of the large organizations, what they're facing is what's the appropriate level of investment and what do we have to do? And because there is a mandate that dictates that you have to do it for all new program startups, just to be compliant, you must engage in digital engineering practices. When you have a company like Anduril, it's easier to deploy digital engineering across their organization or enterprise because they're a smaller organization, they're going to have access to some of these advanced capabilities a lot quicker. It's very difficult to migrate large PLM systems, large MBSE environments across an organization like Northrop Grumman that has tens of thousands of engineers. When you've got 100, 200 engineers, I can deploy that really quickly and have some of the most state-of-the-art and most comprehensive ecosystems, which makes it a lot easier to engage in rapid prototyping and going through different configurations and effectivities really quickly in that type of ecosystem. So I can do AOAs a lot quicker, where it's a little bit difficult to turn a large ship.
That's an aircraft carrier. It's very difficult to turn one.
Yeah, and I believe that term is organizational inertia. I think that's what, where it's difficult to have new technologies change the inertia of the organization in which it was already going. And you have to, realize that a lot of these executives, digital engineering is new to them. They're used to the old ways of the traditional ways of engaging in engineering with disparate technologies, and that a systems engineer may only focus on one area, and now they're having to engage in multi-physics and mission engineering and model-based systems engineering, and they're doing test and evaluation a lot earlier. So the game is changing rapidly. How executives are going about implementing it is difficult. I think what we saw early on were a lot of organizations were trying to deploy enterprise-wide instances, and that takes a very large amount of capital. I mean, we're not talking these are 9-figure investments to get stood up over the course of 3 to 5 years, where now they're seeing, well, hey, maybe if we standardize our data models and we standardize our deployment strategies, we can do it more organically on a need basis, program by program. So I call it the holy grail versus the organic deployment strategies. So, but yeah, it's definitely an interesting time in seeing that how companies are going about doing this.
It's capital intensive, but it's also resource intensive. You need help.
Absolutely. And one of the things that you bring up a really good point. Any vice president of engineering, at the end of the day, they know that their compensation is tied to the performance of the organization, and how do you translate that to the bottom line value? And so one of the things that any VP of engineering hates is indirect labor. We love direct labor charging. And when you're talking about deploying digital engineering, what you're signing up for is re-examining your processes which are typically associated with indirect labor. And that is if you have to go back and address your command media or corporate policies and engineering processes and rewrite that, that's a labor intensive exercise, not to mention everything that's associated with the deployment for those systems and the upkeep and maintenance. So yeah, you're absolutely right.
How can Ansys help these, they call them traditional companies, lean into this transformation that, as you clearly stated, is mandated?
Yeah, one of the things that I think Ansys is very well known for are multi-physics and solvers. Even in the traditional engineering practices, where we really shine is that we have open architecture ecosystem. So we not only play well with our tools, but whatever your existing tools are, we play well with those. We really start to shine when you start getting into multi-physics and leverage the power of Ansys through integrating maybe your fluids with mixed structures or electrical optics. We also specialize in tool chaining and automations, integrating AI, doing mission engineering. Think within the mission engineering space, a lot of people are familiar with our STK platform, where we have 3D physics-based environments where you can test your assets. And so when you look across the Ansys portfolio, no matter which domain or discipline or specialization that you're focused on, we have those tools where we can meet you where you are and then also help you with speed and accuracy and, creating automations to shorten the time that you would have or what you would traditionally have. So we can shift that to the left significantly.
Open architecture is the future. We're seeing it in being developed with LLMs now. They're all open source and open architecture. It's accelerating innovation and development, but you're dealing in a lot different environment than a developer making an LLM. You're dealing in a very, I'll call it secure, controlled environment. With Ansys' open architecture, how do you ensure that all that data is secure?
So one, we have our SPDM tools where we have our own ASOTs, and we're, depending on what your security needs are, we can have that whether you want it on-prem in a classified environment or in cloud. We have GovCloud environments that we can secure that data as well. But when it comes to data transfers and handing off models, between suppliers and customers, we like to keep our hands off of that. That's up to the environment in which you create between your customers or stakeholders.
And so you're just dealing with them with the requirements based on, if you call it the level of classification, depending on the project that you're working on. You just work within those parameters?
We do. And we do at AGI, we do have cleared personnel with TS/SEIs, so we can meet and support customers if they're willing to brief us into their programs. We can go behind the closed doors and have those conversations and help establish those environments and help them meet their DE requirements.
You're establishing the environment, you're keeping them secure. Then the next part is, how do you train individuals to work on these systems? It is a new tool set, and you're going to need to know new skills.
Yeah, and that's great. So great question. One of the things that we do is we want to understand what is it that you're trying to solve. Instead of approaching a team or organization on, hey, this is Ansys, here are our tools, here are our capabilities, we take an opposite approach of what is it that you're doing? If you're working on an EOIR system, what is important to you? What is important to your customer? And what are your current processes? We like to examine what are your pain points? Where do you want to see improvements? And then what we do is reach back to our ACE organization, which stands for Ansys Customer Excellence. We reach back and create a custom program and a custom support initiative to meet those needs. So if it's basic one-on-one training on materials management, or if it's something more advanced where you're needing to learn scripting or integration, or like you said, sustainment, we can do those things, but it's really based on what your needs are and what are you trying to achieve. And we also will do and perform SIM assessments to help you benchmark where is your organization in relation to other entities within your enterprise, and then also externally.
It's helpful. Then you're preparing your customers for the future. Then you can also say that you're future proofing them because you're helping them getting ahead of trends. Staying on that, Dr. Sinclair, sir, in your opinion, what is the future of digital engineering for DoD and government applications?
Well, I would say we know for sure MBSE is going to transition to SysML v2. We also know that AI has been integrated in multiple different and just various fashions, from leveraging large language models for helping engineers with standards and practices execution. But now we're starting to see digital twins start to grow a little bit more. I do see that autonomous or bidirectional data flows from physical artifacts, updating models. That's on the forefront. I'm not sure where we are. I think the next big thing we'll start seeing, and I know NVIDIA is big on training AI agents. I think AI agents will be one of the next big breakthroughs that become very disruptive. I think we will only go as fast and as far as legislation and policies allow us to go. Because at the end of the day, if you're still talking about building an aircraft, there's still physical test requirements that have to happen. And at what point, how far are we willing to allow simulation to replace physical asset testing? And I think that's a question that's still yet to be answered. We are seeing some of those physical tests being reduced by simulation, and there's oftentimes certification via simulation. But I think we're going to get to a point where we will be limited by legislation, and technology will start outpacing that. And that's going to be the big key. What is the government's appetite for allowing technology to push forward? I think that'll also be predicated on administrations and what their focuses are.
Legislation is a hurdle that's going to have to be overcome. We know historically the business world moves faster than government, and there's a big trend that's been emerging over the last 2 weeks. Now it's really going to intensify because the FT did a big write-up on it today, where businesses are becoming publicly AI first businesses. We saw with Shopify, we saw Aaron Levy from Box come out today. Inside of defense, when do we get certain departments inside of DoD that come out and proclaim that we're AI first departments? Or is that going to rest on legislation again?
I think that still rests on legislation. I don't want to, I'm definitely not going to articulate an opinion here, but I definitely think that we are at a time where this legislation sees a big need for change. What does that change look like? I'm an old flight test gentleman myself, so I've gone through F-35 and Triton MQ-4C. So I understand those type of environments where there's things put in place, policies and procedures put in place for safety of assets, safety of personnel, safety of tests. But we are also in an environment where our threats are outpacing our ability to get assets to the field for our warfighters. And that's essentially why we're all here, is to protect our warfighters, to shore up our national security. And so we have to be able to get these products produced, manufactured, and into the warfighter's hands at the speed of relevancy and need. And I think that's one thing that is a consensus across the leadership of the DoD. At what costs or what risks are we willing to incur would dictate what policies and procedures and mandates need to be revisited. And I think that's going to be the moderation of our DoD advancements.
Well, we all know that security is going to increase for national security, and it's going to keep the men and women out of combat in certain situations because the technology takes over with the drones and the automation, as we're clearly seeing. through DoD. Dr. Sinclair, this has been a fascinating conversation. As we look to wrap up for today, sir, what would you like our listeners to take away with them?
I would say, digital engineering is still in its infancy. We're still learning what does it take to be successful. There's a bright future within this industry. If anyone is looking for a career change, there's no dead moment within this space. I also would like to encourage those who have been engaged in engineering with very disparate tools and processes to be open to the change because it's coming whether we want it or not. And don't be afraid to explore the possibilities of new capabilities that we haven't seen before, because I think we're going to start seeing them in new ways that should excite any engineer that has a mind of curiosity and exploration.
Curiosity makes the world go around. Digital engineering is a growth opportunity. Today is tomorrow. Tomorrow is today. The future is digital engineering. Dr. Sinclair, thank you so much for coming on SAE Tomorrow Today.
Thank you.
Thank you for listening to SAE Tomorrow Today. Be sure to join us next week as we discuss A&D Technologies, custom simulation and automation solutions, and how they can transform vehicle testing and lab management.
SAE International makes no representations as to the accuracy of the information presented in this podcast. The information and opinions are for general information only. SAE International does not endorse, approve, recommend, or certify any information, product, process, service, or organization presented or mentioned in this podcast.